Hi, welcome back. So in this video, we are going to discuss correlation coefficient for ordinal variables. To be more precise, we're going to concentrate on Spearman correlation coefficient. Okay, so in general, there are several rules for deciding when you have to use Spearman correlation coefficient instead of Pearson correlation coefficient. So for instance, variables are ordinal, you go for Spearman correlation. Variables are not distributed normally, the same. The data includes some outliers, and the relationship between variables is nonlinear, you go for Spearman correlation coefficient instead of Pearson correlation coefficient. So let us get back to the notion of ordinal variables, even though I believe we discussed it later. So the rule is pretty simple. The variable is ordinal when you can detect some hierarchy which corresponds to the value of the variable, but you cannot clearly interpret the difference between the values. For instance, you can consider the pain score. So you know that pain score 8 is worse than pain score equal to 4. But you cannot say that it's 2 times as painful as pain score equal to 4. Similarly, you can consider star rating system for hotels. You know that 4 stars hotel is fancier and better than 2 stars hotel. However, you cannot say that 4 stars hotel is 2 times as good as 2 stars hotel. So again, there is some hierarchy. This hierarchy corresponds to the value of the variable. Still, you cannot really interpret the difference. So in case of ordinal variables, you can still calculate correlation. However, this is not true in case of nominal variables or categorical variables which are non-ordinal. So in case of nominal variables, the idea of correlation is just non-applicable. Imagine, for instance, that you do some medical research and you want to analyze the link between hair color and pain tolerance. So when it comes to pain tolerance, probably you can design some ordinal variable, as discussed a second ago. However, when it comes to hair color, there is no chance. So you know that there are blondes, brunettes, people with red hair, and what is the criterion here? What is the hierarchy? So you can still go for parametric and non-parametric tests of your choice depending on the properties of data, but correlation is not really applicable here. Okay, so finally, let us discuss in which cases Spearman correlation coefficient is applicable when it comes to monotonicity of the function. So previously we discussed that Pearson correlation coefficient is applicable only in this case, when we discuss linear relationship, which is of course monotonic by definition. The sign of the slope is always positive or always negative. So any linear function is monotonic by definition. We also discussed that not always this is the case. Function can be monotonic. I mean, the sign of the slope is always the same, or less formally, the function is constantly increasing or constantly decreasing. So Spearman correlation coefficient is more tolerant. So even in this case, when you deal with nonlinear relationship, but it's still monotonic, you can calculate Spearman correlation coefficient. However, in case of non-monotonic relationship, Spearman coefficient is not really the case. So in this case, we are still unable to apply any kind of correlation coefficient. Okay, so after discussing this, let us proceed to the formula. So here, D stands for difference in ranks in the pair of observations, and N stands for the number of observations. So as most of non-parametric tests we discussed in the previous lecture, Spearman coefficient is calculated based on ranks. So let us consider the following example. We have 8 hotels. We know their star rating and we know customer rating. And we have to detect whether there is any correlation between the number of stars and customer rating. And the first step for calculating Spearman correlation coefficient is computing a rank for each observation for both variables. So basically you can notice that some values are highlighted in red, and this is because we have tied values. So there is a same number of stars for several hotels. So for instance, for the first, the sixth, and the seventh hotel, the number of stars is equal to 1. For the second and for the fifth, the number of stars is equal to 2. So in order to compute a more reliable result, it's actually useful to use the common rank average in Excel, if you're using Excel for this purpose. So here, for instance, we have 3 observations, 1, 1, and 1. So normally it's the first, the third, and the second observation. And we calculate simple average. So 1 plus 2 plus 3 gives you 6. You divide it by 3 by the number of hotels with 1-star rating, and you get rank equal to 2 for each of them. Similarly, we proceed in this case, for 2-star hotels, and finally we've got the rank. When it comes for customer rating, it's relatively easy because all those values are different. But yeah, when calculating Spearman correlation coefficient for tied ranks, it's more useful to calculate the average. Sometimes you go for geometrical average, but from my perspective, it's not really needed. Okay, so having this done, we have to calculate difference in ranks. So basically, you subtract this from that or that from this. It does not really matter because anyways, we are going to calculate square difference. So here we are. You will end up with the positive value inevitably. And finally, you have to calculate the sum of square differences in ranks. In our case, this value is 2.5. Okay, after that, we can actually use the formula for calculating Spearman correlation coefficient we discussed earlier. So we have 8 observations. The sum of square differences is equal to 2.5. So our correlation coefficient is equal to 0.97. So the value is pretty high, and we can conclude that there is a strong positive correlation. Again, we are not discussing linear relationship in this case between the number of stars and customer rating. However, even keeping this in mind, we do not know anything regarding the level of statistical significance. That's why you can use this table. Again, you have it in Appendix D in your textbook. So here we've got 8 observations, and we have values corresponding to the different values of alpha, or the level of statistical significance. Here everything is for one-tailed test. For two-tailed test, as you remember, you have to split them by half. So we know that our correlation coefficient is significant even at 0.005 level of significance. So here we are. But of course, we do not discuss it that often. That's why it's enough to conclude that it's significant at the 1% level of significance. Okay, so actually that was it when it comes to Spearman correlation coefficient. Hope you enjoyed this video and see you in the next one.